Okay, so for this one you had asked, is it divisible by anything? And that you had tried 2 and 3, and no, it isn't. And that's a great thing to check because sometimes that's the case. And this one, just we got to do these big numbers. So let me show you how to go at it. We're going to group the x's together, we're going to group the y's together, and then we're going to bring that 81 over. The other thing with these x's being together, I'm going to take out the greatest common factor on those on this next line, since they're already written next to each other. And what that's going to do is get me moving in the direction of being able to write this of the form like a plus b quantity squared, or a minus b. So I'm trying to get where this is a 1, so what I'm going to do is I'm going to factor these things out and get those out front. Let me do that now. Go back to there. Okay, so I'm going to take 16 out of these terms involving x. So that will leave me an x squared, and that's what I'm trying to get, is a plain x squared in there. 16 goes into that 6 times. And then I'm going to go plus, and I'm going to leave myself some space there so that I don't have to rewrite all this, because I'm going to complete the square on this next step. Same deal here. I'm going to factor out a positive 9, because that's going to get me a plain y squared. So notice I'm factoring whatever's in front of the squared terms. And then right here, that's going to leave me a negative 6y. And again, I'll leave myself plus with a little bit of space. And I'm going to bring this 81 over, so that will make that a minus 81. Okay, so then next I'm going to complete the square. So let's do, we'll do x first. Half of 6 is 3, and 3 squared would make 9. So that's, I'm doing half of the middle term and squaring it. And then I need to add that to both sides, except that's not really a 9. That is really a 16 times a 9. So 16 times 9 is 144. So over on this side, I have to add 144, because if I distributed this out, like I said, that 9 is actually plus 144. So I'm adding 144 to both sides. And then over here, half of 6 is 3. 3 squared makes 9. So I'm adding a 9, but it's really with a 9 in front multiplying it. So if I did that distribution, this is really positive 81. And so that's where we're adding to that side. And that's the tricky part. So if you can get to there, now we would have 16. This would factor down to x plus 3 quantity squared, and that's where we're trying to get to, is where we can see our h and our k. And then this is going to be 9 y minus 3 quantity squared. Those 81s are canceling, so I'm left with that 144 there. And then the last thing we have to do, so this is 144, but remember, for the equation of an ellipse, this always equals 1. So what we'll do is we're going to divide everything by 144 so that this comes out to 1. And when I do that, oops, there we go. So this will reduce 16 went in 9 times, so this is going to be x plus 3 quantity squared over 9. And then 9 goes into this one 16 times. So that's going to be y minus 3 quantity squared over 16. And now that equals 1. And now I'm in that standard form for an ellipse. So from this, I know that my center is negative 3, 3. I know that this is going to be one of the tall, skinny type ellipses, because the big number is under y. So my major vertices, my a is running up and down, and my b is running side to side. And so a is the big number here, so that's actually a squared, so a would be 4. And then this is b, and then that would be 3. And then once you have those two, that's where you can do your 4 squared minus 3 squared to get your c squared, like I did in that other video earlier. And I think 16 minus, that's the same, 7. And then root both sides. And then that gives you your value for c for when you have to find your faux c down here. I threw this in Desmos just so I could kind of point rather than try to draw a graph on here, because that doesn't work very well. So let me hop over there. There we go. So here we are with our center at -3, 3. And then to get the coordinates for my major vertices, the endpoints of the major axis, that's these two. I would count if I were on graph paper and, like doing this on a paper and pencil test, I put a point here and I go, okay, my A is 4 and it's under my Y, so that means it's going to go up 4 and down 4. And then I would just read those points, -3, 7 and -3, 1 straight off the graph. So that would be my major vertices. And then my B was 3, so from the center I would count over 3 and over 3, and then that gets me those minor vertices right there. And then, like I said, once you know that C is √7 over here, that's just like that other video where your √7 is about 2.5-ish, 2.6. So that means it's right here where X is -3, and then you're saying 3 plus √7. And then your other one would be down here where the X is still -3, but now your Y would be 3 minus that distance √7. And that would be those foci right there. I think that is all of it. The standard form thing, I think that's where they want you to write this 3 squared and 4 squared, which is silly, but that's what it wants. Cool. Let me know if you have other questions.